You know, I love when a video just comes together. Back when we started talking about the Steam Deck, I speculated that Proton would enable FSR across any game that runs Proton. And surprisingly, somebody in the comments actually said you could do exactly what I was speculating in that video. That is incredible. And when you think about it, it makes a lot of sense that this kind of feature would already be on the way, with AMD being so open and Linux being so open, and just the two of them working together to make something incredible. And I installed Linux on both of my gaming PCs recently and started playing around with these features, trying to figure out how to get it to work. And in the last video, you guys actually saw, I actually did all of the footwork necessary to make FSR work across any game on Linux. So today, I'm gonna show you how to turn it on, and I'm gonna show you why you'd wanna turn it on, and how it's going to make the Steam Deck an absolute beast of a handheld. So let's get into it after our intro. Hello and welcome. My name is Wolfie and you are watching GreaterThanPie. So on our Linux journey, we have gone from not having Linux to having Linux, gaming on Linux, making it better for gaming, and now we're about to make it better than Windows all of the time with one feature. Specifically, that will help older hardware. I'm adding a lot on top of this to lampshade this because technically speaking, FSR and DLSS for that matter are kind of hotly contested amongst the communities that run these GPUs. You see, FSR and DLSS to that extent are not native rendering. It's interesting because it is the future, and I really do believe that we'll be using technology like this with indistinguishable quality between native and upscaled rendering. But the way that it works effectively is an image is rendered at a lower resolution, and then using some magic smoke, it turns to a higher resolution image. In the past, this would just be called upscaling, and you would kind of get a blurrier image because not every pixel would line up. But with FSR and DLSS to that extent, they do predictive pixeling. And so effectively, like the same 1080p image being blown up to 1440p will have the pixels added back in through, computing. But to be completely honest, it's contested because, well, it doesn't always look as good as native. In fact, most of the time it does not. In fact, actually the way we're doing it definitely does not, but it does look better than the original resolution. Problem is, currently, the way that FSR and DLSS are set up is each developer has to add it to their specific game individually. And as you can imagine, this is a problem because much like Hairworks from NVIDIA or Radeon Boost, which unfortunately has both a default and a non-default version, there are reasons why developers would implement one over the other, and it has a lot to do with the dollar, to be completely honest. But FSR has something up its sleeve that DLSS does not. You see, FSR is open source, and that means that users can add it to whatever they feel like. But what we're doing today is a janky but appropriate way to implement FSR to force it to work on all games. And I'll be honest, the results are actually really promising. So much like my last video, we're actually gonna use the same set of games. And let me refresh you on these Windows numbers because these are the actually important ones. So for Windows, we tested Devil May Cry 5 at 140 frames per second. Outer Worlds ran at 80 frames per second. Witcher 3, 95 frames per second. Doom Eternal ran at 160 frames per second. But now we gotta turn FSR on to beat those numbers. And to do that is a little bit more difficult than just toggling a switch in the menu because the menus aren't meant to do it. First things first, much like in my last video, you need to have Glorious Egg Roll installed. Now, once it's selected, you do need to select one thing from the game that you want to run FSR on. You're gonna actually have to add this line of code right here. I'm gonna pop it on the screen, I'm gonna put it in the description. Just copy, paste, and it's done. That's it. Honestly, from here, it's a little weird. FSR requires certain resolutions for it to upscale to. If you are rendering at native resolution and you have this line of code in, it actually won't enable. It just won't do anything. But if you change the resolution to a resolution smaller, it will upscale to that higher resolution and it will turn FSR on. In fact, actually, you can see something that looks absolutely atrocious by downscaling slightly instead of to one of the targeted resolutions, which are on this list right here. Honestly, what I have found that works the best is actually the 1080p performance. So selecting 1080p and upscaling the 1440p actually has resulted in a pretty clean image. Like, it's not gonna do any justice through, YouTube's compression algorithm, but I've got lots of footage of 1080p being upscaled to 1440p, being downsampled back to 1080p thanks to YouTube and OBS. I could probably capture it at 1440p. I'm not willing to try to figure that out right now. But digressing a little bit, that is the performance that I'm actually getting. I keep my performance metrics on the screen at all times so you guys can even see them. Seriously, performance just goes through the roof and it doesn't look bad. In fact, actually, in some cases with FSR on, I actually prefer it to the native image. And we'll talk about those in a minute, but let's talk about specifically these games right here. So for The Witcher 3, we went up to 100 frames per second. Devil May Cry 5, 165 frames per second. Doom Eternal, 165 frames per second. Outer Worlds, 95 frames per second. Now you're gonna notice something here. Every single one of those are higher than Windows. That's right, we beat Windows in Linux by doing this. And realistically, we got within an eye shot of Windows through just glorious egg roll. But with FSR enabled, we are capable of blowing past our original Windows numbers because, well, they're easier to render. And if this feature were something that could just be turned on Windows, we'd be able to even blow past these numbers. But I mentioned there are some cases where I prefer the FSR performance to native resolution, and that's actually Borderlands 3. Now, Borderlands 3 has one of the most impressive and difficult to run ultra settings. The Ultra Badass is what it's called, and it is impossibly hard to run at 1440p. It shouldn't be. I mean, honestly, it's Borderlands. Borderlands 3 on low looks like Borderlands 2 on high. But Borderlands 3 with Ultra Badass looks amazing. This footage that you guys are seeing right now is rendering with FSR. It just looks so good. I've used this footage a couple times because it's just, look at how nice it recorded. Like all this stuff, it just looks good. But it is rendering technically at a lower resolution and then scaling up to 1440p. And then, as I said, we're doing all sorts of weird stuff to get there. But with it there, I've found that it just is amazing. And the frame rate is good. 160 frames per second, Ultra Badass, and recording at the same time, and it's not hitching because my resources are not being used as heavily. That's another reason to actually use FSR as opposed to native rendering in some cases. As mentioned prior in videos about recording video, you want to actually lessen your GPU's load below 100% when you record. And the reason for that on AMD GPUs is that 100% of the die can be used for just graphics rendering, and it will always prioritize that over recording, and that will result in hitchy, choppy footage. But with FSR, you can lighten that load, cap the frame rate a little bit, get it to like where it's just at your refresh rate of your monitor, and bam, now you have amazingly fast gameplay, incredible graphics, your GPU's not cranked, and you can get a recording in. Like, it's a win in all situations there. But that being said, you also probably can't tell the difference in the YouTube video between native and this, and that's because compression. So I guess use FSR based off of your applications. If you don't like how it looks, then don't worry about it. Don't turn it on. There is something that I do have to address. Using FSR in this way affects the HUDs in some weird ways in some games. Devil May Cry had some weird artifacting on the HUD, and it's entirely FSR's fault, and I'm well aware of the fact that it is FSR's fault. Doom Eternal had some over-sharpening issues in some places, but again, this is just because we implemented this in a janky way. And believe it or not, there's actually something even crazier that you can do with FSR that I did do that makes it better than native, but harder to run. So let me explain this one, because this one's a little complicated. So let's say you have a 1440p monitor. Both AMD and NVIDIA GPUs will allow you to do something called oversampling. Now, oversampling does result in a better image than native, but it is harder to run. Usually you can run at, like, say 4K and downscale it to 1440p, and of course it will look better, except for text, but it will look better, and then just not be really natively displaying that 4K image. We'll talk about that a little bit more later when we talk about virtual super resolution, but effectively this is one way to get a nicer looking image than what is natively displayed on your display. And capture also does benefit from it. But doing so does make things more difficult to run. So what if we ran it at native, used FSR to go to the upscaled resolution, and then downsampled back to the original resolution? Yes, I tested this. No, I should not have, but it does result in playable frame rates in games that already ran well at 1440p that look better than 1440p. It looked better than native. Granted, I would not use FSR in this particular way, and to be completely honest, it's kind of pointless to use it this way. FSR is best used on hardware that is struggling to run something, not to create a situation that becomes harder to run something. But that being said, my general experience with it on Linux has been pretty awesome. And it makes me excited for what the Steam Deck holds, because you see, the Steam Deck isn't the balls to the wall, high powered gaming PC that Supernova or Dark Matter are. No, it's limited. But it's limited, and it could theoretically benefit from FSR, particularly when docked. You see, I'm not worried about the handheld performance. I think this thing's been tweaked pretty well, actually, for handheld performance. I did a video right up here for that. Linus, actually, his numbers were less impressive than mine, but I think I had dynamic scaling still on. Digressing a little bit, like, I think that there's been optimization for Proton, plus, as I said, with Glorious Egg Roll and things that we've talked about on this channel, I think you can get the Steam Deck to a really impressive portable handheld performance. But I am worried about its docked performance. And that is because, well, it doesn't overclock when docked. And when we tried the same experiment that we did in the video prior, our 1080p performance wasn't great, and 1080p would be kind of like the bare minimum to aim for a monitor to put on a screen. So FSR might actually be the secret sauce, because if it can run at 720 and upscale using FSR, it's not gonna look as good as what we did today, but it will look better than if it were being run natively. So yeah, I'm excited. It works. Go ahead and try it out. I mean, Linux is free, so if you've got a Linux distro running, go ahead and give this a shot. It's super easy to do. And yeah, performance-wise, it's worth it. But I am gonna address a bit of an elephant in the room. I also got this working on Windows. Yeah, I actually got this working on Windows. Granted, it's not a free solution, but it does work. And I did test it, and we're gonna do a video about that pretty soon. Probably there'll be some other things mixed in between, because, you know, I try to have a variety and not talk about the same thing over and 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 over again. Point is, there's a video coming about running FSR on Windows on all games. And unfortunately with Linux, it's not all games yet, because, well, you have to get the right version of Glorious Egg Roll that works with the version of the game, and some games don't like it still. I've found that that's been the biggest headache and hurdle with it, but to be completely honest, it's once you know how to fix it, It's not too hard. But that's where we're gonna end today, guys. So thank you so much for watching. If you enjoyed watching this video, you can leave it a like, comment, subscribe, and I will see you in the next video. Wolfie, out.